Let's look at question 3e. You are supposed to find three things. First, the inverse function. To find inverse function, I'm going to swap the x on y. So x equals to 1 on y squared plus 1. Making the y subject of formula, you're going to get this. And then y squared is equals to 1 minus x all over x, and y equals to square root of 1 minus x over x. Now, square root function will give you a positive side and a negative side. And whether we're going to pick the plus or minus depend on which section of the original function I'm looking at. I want when the function is monotonically increasing. All right, so this is where I have to look back at the original function and figure out when is the function monotonically increasing. What 1 on x squared plus 1 graph look like is this. How do we know this if we're not very familiar with this kind of curve? Well, you can plug in a couple of values. I know this curve is y equals to -1 over x squared plus 1. Imagine if x is equals to -10. What you're going to get for y is y equals to 1 over 101 plus 1. Sorry, 100 plus 1, which is 1 over 101. Okay, so when x equals to -10, the y value of this coordinate, okay, the y value of this coordinate is 1 over 101, which is a very small number. As we move progressively to the right-hand side, so to the more positive side, okay, I'm getting to this point now, where x equals to -1. Well, x equals to -1, y equals to 1 over 1 squared is 1, 1 plus 1 is 2. Okay, so this corresponding value here would be about 2. Okay, this is not very accurate, is half. It's not very accurate, but you get the gist. The value of y is increasing as x is going to, as x goes more positive, y is actually becoming bigger. Now, when x is equals to 0 at this point, what's the y value? Y value is 1 over 0 squared, which is 1. So 1, so the y-intercept here is 1. Once we get to there, on the right-hand side of the y-axis, okay, what happens is when x equals to 1, what happened to the y value is y equals to 1 over 1 squared is 1. 1 plus 1 is 2. So here, when x equals to 1, y becomes becomes half. And then as x becomes progressively bigger, let's say 10, y will become progressively smaller. So you can see over here. So when x becomes to 10, y value becomes progressively smaller. So which part of this function do I actually want? Well, I want it when the function is monotonically increasing. In other words, I want this part of the graph. That's the negative side of x. Okay, that's the negative side of the x. So in other words, I want the negative side of the square root. The inverse function is this. Let's now look at the second part. The second part is asking for the domain and range of the inverse function. So I know that if I find the domain and range of the original function, I can then find the range and domain of its inverse because it's just swapped. So I know that for the original function, right? What is the domain? Well, domain for the monotonically increasing part, which is the highlighted part, is between -infinity to 0. Non-inclusive, okay? It is non-inclusive on this end is because at point x equals to 0, this point is a stationary point, which means that it's neither increasing or decreasing. If you think about it, it's increasing all the way up to this point, and then it's going to go back down, right? So that part is not monotonically increasing, it's actually stationary. For the range goes from 0 up to 1, and it will not get to 1 because I'm not including 0, and it will not get to 0 either because 0 is asymptote. It becomes smaller and smaller towards -infinity when x becomes -infinity, all right, when y becomes closer and closer to 0. So if that is the case, then what is the domain and range for the inverse function? For the inverse function, therefore, for the inverse function, the domain is all the x's in between 0 and 1, and all the range such that range y is in between -infinity to 0. Coming on to the last little part, sketching the inverse function then just says, okay, well, if the original function is this part, going up to 1, then the inverse function is reflection on the line y equals to x, which means the inverse function starts at 1 over here and it's going to go down, closer and closer to the y-axis, but not really touching it. Okay, so it's like a wriggle like that. You girls probably can do slightly better than me. Okay, closer like that.